Good afternoon, everyone. My name is Pranjal, and I am joined with Mr. Bhaswata Chaudhary and Samunder Singh in remote. So, the name of our team is Synapse, and the name of our project is Shruti Dishti. So, the problem that we have chosen and we are aiming to solve is to address the communication gap between the deaf and non-deaf community, particularly Southeast Asia and particularly India. So Southeast Asia, as we know, is home to a large, significant amount of global deaf population, and the figure suggests it could be as high as 63 million. So the lack of accessibility and communication tools poses a large challenge for education and employment opportunities for such deaf community. So the government has tried to establish Indian Sign Language as an official language, but more innovative solutions are needed to bridge the communication gap. So to address this problem, the approach that we are choosing is proposing three solutions. First is text to sign conversion, second is sign to text conversion, and the third is multilingual support for more AI inclusivity and inclusion. So the code can be found in this repo, and let me just go to the structure of the code. So as you can see, we have these measured directories, and each inside the backend folder you can find these four subdirectories. Each is a module, and each has its own README and its own how to set up and everything. So now let me explain our flow. So we have tried to use three basic modules. First is sign to text conversion, second is multilingual support, and third is text to sign conversion. For sign to text conversion, we are using Vision AI fine-tuned models. For the models that we have chosen is two models. First is temporal LSTM, the second is video MAE transformer. For the multilingual support, we are using AI for Bharat's Indic transformer, and we have used quantization and batch normalization, and we are proposing support for 22 Indian sign languages. And for the text to sign conversion, we first saw a paper to convert the text to gloss and gloss to video, but we went with a new approach, and we used agentic workflow to take the input sentence and use an agentic query, and to manage the state management we use LangGraph, and the final output is a video based on the input query. So for the translation, we used quantization by bits and wires, and West translation is also available. So let me just show. So this is a sentence. We can select any of the target languages. We have 22 sign languages, and we can click on generate, and we get the translated text. So this is one of the multilingual translation feature. Next is text to sign conversion. For text to sign conversion, first we take the user input, and then we generate the list generator agent, and then I would urge into.
So, good afternoon, everyone. So basically, what we do is that the user input is separated into its corresponding outputs. Assuming the user input something like "Good afternoon, sir" or "Good afternoon, ma'am." So what will the agent output? It will output "Good afternoon, comma, sir" or "Good afternoon, comma, ma'am." It's made in such a way that it gives a very structured output. So what we are doing is we are constraining the AI LLM to give only a structured output. All of the LLMs, validation checks are done via Pydantic. So we make sure that the output is structured, and output is passed from the only inputs that we allow it from. So it's broken down into blobs. So good morning, sir. Now what happens is that we have two verifiers. One is COT verifier, one is cross verifier. COT verifier basically forms a chain of thought on how we are doing it, and cross verifier basically double checks whether our output is correct or not. So according to this, we are retrieving a video from the blob itself, from the names generated by the list generator agent. We get these blobs as outputs, and then we stitch them using FFmpeg, and we get a final output video.
Before moving further, let me start the inference process, and you can continue with the demo. So I will show the video conversion of the same sentence that you used. And so the sentence is a student with pink skirt on Sunday evening. So we will generate the video, and it will take some time, so we'll just continue with our presentation.
So this is how I have structured the blob classifier. We can see the blobs are literals. So it is restricted to certain inputs and inputs only. We have CO2 region and we have a cross verification, which is a bool itself. And we validate it via pydantic output parser like this. And this is the basic workflow that how we have structured our workflow. Next.
After conversion of the globs, we merge the signed videos and merge them into a single video using FMPEG and rerun the video. Now for the text to sign demo, so the sentence that we passed, this has been broken down into gloss using the agentic workflow. After broken down into gloss, we fetch the corresponding videos and then merge them and we get the output. So let me fetch the output. So this is the output. So this is the sentence that we gave, and this is the sign language generated for the whole sentence. So this was all about text to sign demo. Now for the sign to text conversion, we have used, as I said, LSTM model and video MA transformer. So the pre-processing that we have done is we have done random clip sampling, then frame selection and normalization and some pre-processing. The pre-processing framework that we have followed is, first we are taking the video input, passing it through OpenCV, and then finding the media pipe key points using Google's media pipe, and then saving into an NP array. And these NP array are then also one-hot encoded, and this output, NP array output, is fed to the LSTM model for the demo. Now for the sign to text transformer model demo, so this is a, so he is passing this sign, which is the sign for happy. So the output he has got is happy. For the LSTM output, so this is the LSTM model that we have chosen. These are the dropout layers and the LSTM layers that we have used. We have used time distributed layers and dropout layers. So the LSTM demo, we have made a Streamlit demo to show the sign to text. So this is Samunder, he is showing the sign for loud, and as you can see the output is coming as loud. Similarly, you will show another sign for cheap, and the output is cheap. Now the evaluation metrics that we have received after training on our test set is as follows: accuracy of 0.9, F1 of 0.9, and so on. Now the use case for this model, one of the use cases is that we can use this sign language generation system in offices and educational institutions to facilitate seamless communication, and we can also empower the individuals with hearing impairments and provide them equal opportunities. Another is content accessibility for the text to sign. So any news channel or content creator can take this text input and can generate sign language. This enables them to make their content more accessible and inclusive. So the future prospects are, we are thinking about attenuating the present problems with LSTM models and extending the sign to text with better models, and extend and add speech diarization.
So this was all about our project on the present on the first Synapse.AI.
Because like there were
LSTM.
multiple components. I think it would help if you can like stitch back those things together. Can you go back to that architecture diagram?
LSTM.
No, even previous to that.
One second.
Maybe yeah, I think we'll have to kind of repeat a couple of them. Yeah, yeah. Yeah, can you just go over like, and also within these, which are the parts like are like wrappers around the existing models and what extra have been done? I think that was not coming like coming out very.
Specific contributions.
Yeah.
All right.
So just two more clarificatory questions which you can stitch with the question already asked. The first is when you're generating the video, is it the case that for each word or each sign, you glo- do you already have a video file on the machine and you're just stitching pre-existing video files together? That's the first part. And then the second part is, how did you train the model to recognize Indian signing? How did it get that capacity?
So to clarify, all of the signs that we showed, the demo and everything, all are Indian sign languages that we have taken from ISL dataset that is created by AI for Bharat and include 50 dataset. And for the second question, like, so we are using the agentic LLM to convert the sentence into gloss. Gloss is basically clause. And what we have done is we have taken the include 50 dataset and converted the videos into these skeleton videos and then made into a folder. And then we are just taking the gloss and then merging them into an FMPEG output.
Now, if you can answer her question.
Okay.
Where exactly you work on?
All right. For the sign to text conversion, the model that we showed the output for the sign to text, that is the LSTM model that we have trained on our dataset, and that is our trained outputs. And the second is video MAE transformer. So this is a Hugging Face model. So pre-trained model, we have trained it on ISL dataset, and the output shown is on our trained model. And for the agentic workflow, so as we saw in a paper, the paper uses
So further going on to agentic workflows. So the way I've implemented is very strict. It does validation checks. If the output is not correct via Pydantic, it does chain of thought, and it does self cross validation as well. So the way I have implemented it, I have implemented it in literals, as you have seen in Pydantic input. So I have not, I have yet to see, I might not have seen, but I have yet to see someone implement it the way I have did by a very strict constraint of inputs.
So the way this part is normally done in papers, and this is, they are using positional embedding transformers. So the output of positional embedding transformers is not that great. So we thought of this agentic workflow. So the agentic workflow, the two benefits is, first is we don't need to do stemming and lemmatization, that is automatically taken care of. And the output is very much correct because of the chain of thought and the cross validation. So these are the two benefits.
So this agentic LLM is a paper or it's available tool is what
No,
you
so
say?
the agentic LLM workflow we have built completely on ourselves. We have used a LangGraph to build the entire thing, as you can show. So, so this is the block classifier, custom classifier. This is the Pydantic output we have defined.
How do you train it? Like it's text to gloss, right?
Yeah, it takes the text sentence input.
Let's say in Indian language as well.
Yeah.
Okay.
And it will give the corresponding gloss. So it
So
has a idea of the corpus of the like keywords available, and then it will lemmatize and stematize and find the only the keywords related to that.
So yeah. Have you trained it from scratch kind of thing, like, or is it available?
Not
So
Okay, so let me summarize your talk, okay? Tell me where I'm wrong. Okay, so first is you are given a video, I mean, so in this part, second part, okay? Given a text, you take the sentences and then, you get the video, you run it through some models, I'm assuming, what model are you running through?
LSTM and
No, for the text to, from video to text.
Mixtral 8x7b.
Okay, so Mixtral 7b, and you get text output. From text output, they do stemming, lemmatization, everything, get the just words. Words, they have a dictionary that has a words to gloss, this thing.
So this entire-
Which they also have, hold on one second. They also have a video for each of those words, correct?
Yeah.
And so now what they all have to do is they have to just slot fill into the dictionary, essentially. So it's, yes, so they map it to a dictionary of gloss words and then show those gloss words, essentially.
Yeah. So the
Is
entire,
that's accurate, right?
Yeah, that's accurate. So the entire text to gloss conversion, that is normally done using positional embedding transformers. So we just replace that part using our agentic workflow.
Got it. Okay. But you also use, okay, sorry, okay, got it, okay. So,
So
it is to split it. Once you get the text from Mistral, converting it into the dictionary is non-trivial, okay? And for that, you need to know where to break it, what parts doesn't make sense to break it, etc.
Yes.
For that, they're using this particular.
Yeah, and to make it double sure, you're using chain of thought and using cross validation.
Okay, so they're using extra verifications to make sure that that actually is accurate.
To make sure you're getting the exact gloss,
Yeah.
identical output.
All right. Any other questions?
How do you get that from the text to the token mapping? How is that trained? Like, how do you get that?
So, okay, so here, exactly here, we can see we have specific tokens, right? Dry, parent, sign. So what we have done using Pydantic, we have instructed the LLM to only and only limit the outputs generated in this format among these outputs. It can't return anything else. If it returns something else, we throw a validation error.
It's more like a phrase gets mapped to any of these tokens.
Yes. So we are using the fact that LLMs are very good natural language processors. These natural language processors, they usually come in an unstructured format. We structure it. We make sure that the outputs are correct. We validate the outputs, and only then we fetch the correct appropriate videos. And this can be easily extended by just outputting appending it in the list file and skeleton file.
But
So this
one
is
thing
the
not
workflow. This is the state. Yeah.
like one thing is not clear. Like if some part of the phrase is getting converted to token, for which that like pre-mapped
in the vocabulary.
pre-mapped video is there. What part of the phrase gets mapped to the tokens? Like how is that? I mean, any part of the phrase can get mapped to some token. Now, like how do you validate that? Where do you have a test set for that, or how do you validate that?
So,
Like,
okay.
you got my question, right? Any part of a phrase or any part of the text will get mapped to a strict set of tokens.
Yes.
That I understood.
Yes.
But how do you validate that mapping is correct?
Okay, so
Sufficiency of that.
sufficiency of the output. Okay, so I understand your question. So basically what I have done is that this is the literal thing, right? So what is literal? Let's explore what's literal in Pydantic. So basically, when you define a literal, it can only and only take two values. Suppose for Boolean, you can only define true and false. And similarly, you define a literal, only the specific text strings will be valid. If the model throws something other than those literals itself, the model will throw a validation error. Okay, so now how do we deal with missing texts? Okay, so for dealing with missing texts, we have two approaches. Number one approach is that we can just add it to the list itself, and we can add the validation. Yeah, video. So number two approach is that we skip the word that we don't have. So the only reason why we used a specified set of this predefined outputs is because we have limited compute power. So what we can do is that we can easily incorporate all the videos from include 50 or include dataset itself.
And
So
expand your literal.
exactly.
Yeah. And you can see
one
this is
is
the prompt for the COT chain of thought.
Like sufficiency is one thing, like coverage is one part, but the accuracy is another part, right? Like it's like some part of the text is getting mapped or not. That is like the coverage part, but the phrase getting mapped correctly, that's you're saying that because okay, you're just relying on the LLM doing the right job.
Okay, so to address that, we have generated two things, which is COT for sufficiency, chain of thought. What thoughts are going on in the LLM itself? This is a very powerful technique actually to make sure that the LLM outputs properly. Okay, second technique is that we are cross-validating against the output produced by the LLM itself. Is it self-sufficient or not? Is it more correct or not? We are asking the LLM again and again to cross-verify its output, to self-reflect on its output. Is it correct or not? We are asking the LLM again and again, and we are making sure. You can see this cross-verification is equal to true. right? Cross verification is equal to true. So it's cross verifying. Is it correct or not? And a COT reason also you can see how it has categorized it, why it has done so, and you
All right.
can easily validate it.
Thank you.